Alright, ladies and gentlemen, welcome again to another video where I'm going to be covering the problem 2 of the problem set 2. So I hope you have tried on this problem on your own, and so let's get started. So here problem 2 says, write a function which takes a real number x and return the value of e to the x. And says here, note that e to the x is equals to 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus and so on and so forth for any value of x, real value, doesn't matter, so any value. So the error must be less than 0.001. So here we have a sample input. So if I give you x equals 4, so e to the 4 equals 54.5981 and so on. So how to solve this problem? So the first thing that you might notice here is that we have the factorial function, something we know, okay? And at problem 1, I have covered how to make the factorial function, and I've also covered how to do it at the course. For that reason here, I didn't delete it, I just left it as it is. So the factorial of n, first of all, we declare an answer function equals 1, and then we iterate from 2 up to n, and then every time we will multiply the answer by I, and then finally we return the answer. That's how to do the factorial. Now the second part here is the e to the x. So how to do this? So as when you look to this notation here, you can see that there is a pattern here. So first it's x to the 1 over 1 factorial, and then x to the 2 over 2 factorial, and x to the 3 over 3 factorial. So you can see here this 2 here is the same 2 here. This 3 here is the same 3 here. This 1 here is the same 1 here. And for this 1 here, you can see this one as x to the 0 over the 0 factorial. And by definition, the 0 factorial is 1. Okay, so we can add that to our factorial function. So if n equals 0, then simply return 1. Okay? So basically, as you can see, there is some kind of loop here. Okay, we can notice a loop. We can notice that there is a loop I, some I starts from 0 and up to infinity. It goes to infinity. So x to the 0 over 0 factorial plus x to the 1 over 1 factorial. So it's basically x to the I over I factorial, right? So let's do that. Let's do this idea here. So I'm going to create a function called expo, which will calculate the e to the x. So I'm going to give it a double x value there. And we said that the first thing that we're going to do is basically we're going to do a for loop. So if for I starts from 0, for I starts from 0, and then I++, and I'm going to skip that condition there when we have to stop. But now I want to focus on what is the computation that we're going to do, okay? So let's declare a variable that will hold the final answer. So the final answer will start by the value of 0, since this is a sum. So it's 0 plus 1 plus that plus that plus that. So it starts as 0. And every time we add to that x to the I over I factorial. So that's power of x to the I. Okay? And the power function is defined at the math header. So that's x to the I over the factorial of I. Okay? So every time we compute this value here and we add that to the answer, so the answer gets incremented by that value there. Okay? And we keep doing that, and we keep doing that until what? Well, until one of these terms here becomes less than 0.001. That's the error. Okay, the error must be less than that. It means that the term, when we reach a term where it is less than 0.001, then we stop there. Okay, so the condition will be here in the second parameter of the for loop. So when the power, when that value is, as long as that value is bigger than 0.001, we keep the work. Okay, we calculate until the power of x to the I over factorial of I is no longer bigger than 0.001. At that point we stop, and finally we've got our answer calculated, so we return that answer. So let's return the answer. And now, since here it said write a C function, not a program, so we don't care about the user input or whatever, we just have to create a function and test if it works or not, and then we're done. So let's just add a printf function to test whether our function works or not. So printf a floating value, and then I'm going to give it the expo of 4. Okay, and let's see the result. And as you can see, it's basically the same result. Okay, all right, it's basically the same result. It's 54.59810, and then here we stopped because the error is 0.001. But if we just make the error smaller, we can just make it more accurate. Okay, we can get more accurate answer. So let's make it smaller, even smaller. Let's make it like this, for example. Well, it prints like this because here we're printing it as a float, but we don't care. So the value is correct. Okay, so according to the problem statement, we've got our answer. So that's it for problem 2. Thank you guys for watching, and see you at next videos.